Okay, we're going to look at the last couple of options here with rational functions, two special cases. An example here of the one, and we'll sort of see why in a moment. So what happens, I've graphed it here on Desmos, and we see that we end up with basically a straight line. Now, looking at the original, I think if I had looked at this, or if I'd left this with you to look at initially, the first thing you would think is x plus 3 means that we have a vertical asymptote at minus 3. So surprisingly, in a way, we don't. Now, if I just kind of follow along the graph here, there we go. As I scroll across, you see right here at minus 3, the point is undefined. And the graph should look as it does right now, with a circle in there. When I'm graphing it myself, if I recognize that this ends up being essentially a straight line, but that at negative 3 it's undefined, I put the empty circle in to indicate that one specific spot doesn't exist, but the rest of the graph is a straight line. So I'm just going to go back to the graph here and sort of show what the reasoning for it is actually fairly straightforward. If you had been given this question last year, what you would have done is factored the top, factored the bottom. In this case, the bottom doesn't factor, but and then any terms that appear top and bottom, you cancel, or divide out. And so in this case, when we divide out the x plus 3, we're left with x plus 2, with again sort of the understanding that because I had this initially in my question, and I'm suggesting that x plus 2, this final expression, is exactly the same as the original, I have to make the caveat or state the restriction that that's only as long as x does not equal negative 3. And then graphing it is pretty straightforward. As we said, it's basically just a straight line that goes through those various points of the x plus 2 line, with an open circle here to indicate that x equals negative 3 specifically has what we call a point discontinuity. At that specific point, the graph is not continuous. There's no value at that point. Otherwise, it follows the x plus 2 line. Okay, so that's sort of the first possibility, and it occurs specifically when we were able to divide out a denominator, or a term from the denominator, because we do still have that restriction and we can't forget about that term. Second choice now, slightly different question. I've got the x minus 3, so this is not a common factor with anything on top. Flip back to Desmos here, and we'll put in the x minus 3 instead. And I need to see a little bit more of the graph to get a good feel for what's going on. So essentially I've got almost what looks like a parabola up top and a parabola down below. Obviously not quite, because it doesn't have the parabolic shape. It's actually called a hyperbola. And interestingly, the line x plus 8, if you can sort of see, comes zipping along the edges here. The graph going both directions is actually approaching that x equals 8 line. Again, I can't really see this because I don't have both points going. I didn't intend to have that point show up. But you can sort of tell that it's approaching that line, and the blue line is just ever so slightly above the red all the way here, and the blue line is just ever so slightly below and to the right of the red over here. So yx plus is 8. Well, if we actually do this division, same sort of idea. Last time I was factoring because I knew that the factors would cancel. But if I actually do the math here, which says divide the top by the bottom, when I simplify this, I get x plus 8 on top. I end up with a remainder, but that's really irrelevant. Essentially what it says is, as I'm dividing this by this, again, sort of as we talked about before, our end behaviors, as these numbers get huge, this divided by this is really close to x plus 8. There happens to be a very small remainder on there, but it's irrelevant. And so x plus 8 ends up being my, what we call, oblique asymptote. And it's sometimes simply called a slanted asymptote as well. And so there's actually the equation y equals x plus 8 that I sketch onto my graph, and then I recognize as I'm approaching, as my values go out to positive and negative infinity, so just assume this is my line. My two possibilities, as before, would be that my graph will come up this way towards it, or sorry, down this way, I should say, towards it, or up this way towards that same line. And same idea the other side. It may be coming down towards that line, or down towards this line. And as far as I'm concerned, to figure out which one, I do exactly as I always have done. If I want to plug numbers in here, negative 1,000, put in negative 1,000 into these spots here, 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 we get a number that's either slightly above this one or slightly below this one. But in reality, what's going to happen is, as I fill in the rest of my graph, I will figure out what's going on as well. So that kind of just comes from the rest of the graph. If I know where there's an x-intercept or where there's a y-intercept, I'll be able to tell if my line's going to be above that or below that at that point. Okay, so that's super quick. I apologize, lots of problems with the computer today as far as jumping back and forth. You saw a few of them, but this is by far the best run, so I'm going to save it and post your work and ask questions, obviously, as always, as you need to.